Excuse me, Chirag. Can you hear me? Your
Hello, hello.
voice. Hello. Your voice was not audible till now.
Uh, is it? Okay.
Yeah, yeah. Now it's audible.
Okay. Just a minute. Me, okay. Let me just reconnect my mic. Uh, I hope I'm audible now.
Yes. Yeah.
Thank you. So, yeah, a very good evening to everyone. Uh, it's great to see you all present here today. Let me give you a quick introduction about myself. I'm Chirag Chauhan, an AI engineer at the machine learning company. I will be guiding you for today's session on MCP, which has been one of the most talked topics in recent times. So let's get started. But before directly going into the details, we will take a quick overview of what we'll be covering in today's session. So first, we will understand what is MCP. That stands for Model Context Protocol. We'll talk about its architecture, how it is kind of different from the traditional approaches which we used to take with AI agents, function calling, and stuff. Then we will take a bit more deep dive into the MCP ecosystem. Specifically, we will see the three important features or capabilities of MCP, that is tools, resources, and prompt-based interactions. These are the like kind of building tools that make MCP powerful. Then we will have a look at around how we can make use of fast MCP to create MCP tools, deploy it as a server, and uh, then make use of clouded desktop to actually use the custom MCP tool which we have developed. So yes, now we will actually start with something different. So what usually we see is what MCP is, but before actually understanding what MCP is, it is actually more important to understand what MCP is not, because there are a lot of overlaps, or there are a lot of space where like you might feel that MCP is kind of an API, or MCP like what is the difference MCP provides, right? So first of all, MCP is not a replacement for traditional APIs, the standard API which we used to create. Uh, in fact, it builds on top of them. So think of MCP as an AI integration layer. MCP servers typically act as wrappers around the existing APIs. So MCP tends to actually make APIs more like more of an gateway for the APIs. So the LLM interacts with the MCP server, and that particular MCP server is what actually calling the API behind the scenes. Now, here some of you might get a doubt is, if you had to call the API, why we have to specifically use MCP to call that API? That we will see it later, but think of it right now is MCP is working as a gateway that can help us call the APIs and makes it more friendly for the LLM to identify that API. Secondly, MCP is also not just a function calling for LLMs. Like tools, we have OpenAI's function calling feature where we predefine certain functions, give it prompts. So they often require you to hardwire each function and logic into a prompt flow, how you will integrate a function call, how you will let the LLM identify a function, right? Sometimes the LLM might use that function, sometimes the LLM might not use that function. So the thing, like the difference MCP makes here is it introduces a standard protocol for discovering. So what happens behind the hood is in function calling, the LLM tries to identify what function it has, and then it like based on the user query it decides. But with respect to MCP, uh, it's kind of more about discovering, describing. Like when we create a custom function, the model can read its name or it's read its information, but with MCP you are actually able to define a whole idea behind the function, which LLM will be able to more understand dynamically. And these functions will actually not exactly the functions, the external APIs, the external databases which you have created would be able to integrate with LLMs more easily than compared to function calling. So as we move ahead and uh, describe more about MCP, you will get a more clear understanding about that. Right. Now, MCP is not an LLM or an agent framework. It doesn't contain any logic to decide what the LLM should do next, right? There's no reasoning, or there is no task planning that MCP does. MCP is like a kind of a communication protocol. It enables your agent or your LLM, that is what the actual brain of your system is, to connect with the tools, and then based on the tools which the model or your agent identifies, agent will make a decision and plan a logic how to extract or how to get the correct data to to send a response to the user's query. So at the end, if you think MCP enables better connectivity between the tools or the data sources which are present with the LLM or the agentic framework, then LLM is not a knowledge base or a memory store. Like we speak that MCP uh, can have data sources. It can connect the LLM to the data sources, but MCP is not responsible for storing those data. MCP can uh, guide that. So MCP can actually guide the LLMs to what data they may be able to identify. So that is how MCP does not store any information. It just exposes the data in a structured way that LLM can interact with it safely and more efficiently. So what idea we get here from the overall picture about what MCP is not is MCP is a bridge, not a brain of its own or a kind of a storage. It's just a protocol, not a platform or a database. It's just a connecting bridge between the LLM and the tools and different sets of resources. Right. So now that we know what MCP is not, let's take a look at uh, the MCP architecture, like what actually happens behind the architecture. So first of all, MCP follows a stateful client-server model where the host application, this particular host application, whether it could be a chat interface, a developer ID, or a custom AI assistant running on a website, it can have one or more MCP-based clients. These clients will open a connection with this MCP server, and this communication is based on another protocol that is called as JSON RPC, so which is a lightweight and widely used procedure call protocol. So the server in this setup, like the MCP server, is a very small and a focused program. It is not something very big or complex. Its overall idea is just to expose specific capabilities like access to files, a database, or some external API. So this server can make the client have access to local resources that are running either on a cloud local storage or laptop's local storage or remote services like a third-party API. Meanwhile, the client will manage the session state and negotiate what capabilities are available and what data resources user require and make a request to the server. So that is how clients and session servers will interact with each other and will try to provide the user. So the user would be using the host application, asking certain queries. So based on that, client will make a request to server, identify the particular best tool or resources, and get the response to it and serve it back to the host application for the user to get the final response. Now, we may have a question is why MCP uses JSON RPC, right? So it uses a particular version, JSON RPC 2.0. So this is because MCP is built for two-way communication. So LLMs often identifies what tools to call, but sometimes there can be cases where the server also or the tools residing in the server wants to call back to the LLM for some context or for some clarification. So JSON RPC supports bidirectional communication model which enables dynamic interactions between both client and the server whenever required. It might not be used every time, but the main reason or why JSON RPC is a better approach is because it supports the bidirectional communication model. Right. So this diagram will give us a more clear picture about MCP. So technically, there would be MCP host. The host, it would be an application as we discussed, could be ID, could be some particular website which is hosting an AI agent. This particular host can have multiple clients. Each client will have a kind of a one-to-one relation with an MCP server using the actual MCP protocol code that is working behind under the hood. So how this works is the connection, the MCP client identifies which tool is running inside which particular server, and based on that particular tool requirement and the user's query, the client will ask for either access to database or some external API. The server will run the particular API or some query over the database, and whatever response it will get, it will pass back to the client, and then client using a particular LLM, like whatever LLM we are using, be it OpenAI LLM or Anthropic, Cohere, or any custom Hugging Face, Olama based local models. So this particular models will generate the final response based on the user's query combined with the response from the MCP server, which where some tool calculated the maybe it took some data from API or fetched some data from the database. So the LLM will form the final result and will present it to the MCP host. So that is how the overall architecture would work. So going a bit deeper into the architecture, like a bit more about the host client as server. First, we will take the host. So host, you can think of it as a coordinator and also a supervisor. So it creates, manages multiple client instances. So let's say it kinds of controls the entire life cycle, like permissions. So the earlier versions of MCP, like the tool building capability which we had, it didn't came up with authentication system. And so later on, when they upgraded the MCP protocol, they started involving more security protocols, authentications, then how to handle the connections between clients and servers more efficiently. So it got updated over the past few months. Then this host also coordinates the AI LLM integration and the context aggregation across multiple clients. So if multiple tools are interacting, the host will be able to like coordinate between them, keep the things coherent, and won't let multiple clients mix up the responses between each other. Then coming to the client are more of a session managers. Like each client maintains one stateful session per server. It handles protocol negotiation, message routing, and ensures secure communication between it and the server. Client can also maintain certain kind of like user response. So how that user response happens is if a tool wants to particularly ask a question back to the user, the client can also facilitate that request. So that is how client are called more as a session manager. It handles all the request in incoming and outgoing for the particular user. Then coming to the servers, so servers are the context providers. Servers expose MCP capabilities like tools, resources, and prompts. They are lightweight, focused services. They could be anything, local stores, local programs, or remote APIs. Servers will talk to the client to perform tasks, and the servers should follow the host defined security rules. So technically, whoever defines the MCP host and MCP server, they would have certain security rules defined, and those security rules nowadays comes inbuilt with the servers which you would be taking from the internet. Like if you wanted to set up a server for a database, that particular server will already have all the security rules predefined. Then you might have noticed this word interact with clients, meaning when I explain that the servers will act on the client's request. So there you might have noticed this word called as sampling. So how sampling works is samplings means servers are able to initiate request back to the client or host to trigger LLM actions, meaning if based on a client request, server was not able to run or execute the particular function defined inside the server, it might ask client to identify what was the issue, because client is the place or client is the place where it also gets connected with the LLM. So the LLM might identify if it gave wrong information to the server, like kind of wrong input to run. So in that case, uh, like the client or the LLM which the client has, that LLM will restructure or rethink about the input it gave to the server, and it will send a new input. So it is kind of a, as we discussed, bi-directional communication. That is the reason why we had JSON RPC for ourselves. This allows the recursive workflows where LLM can review its own output and make certain follow-up decisions. Right. So this architecture just it improves the flexibility, gives the MCP a recursive workflow and a very good interactive approaches. Like if we remember with function calls, uh, we need to write certain failure conditions as well, that certain if sometimes function call doesn't give us the response back, we might need to write a custom loop or a custom function where we let the model try the function calling multiple times to get the result if possible. So that is like kind of abstracted here with MCP, because the LLM will itself identify that it is not the required response, or maybe there was an error with the server. So what caused the error, and then it can again return the corrected flow to the server back, and that will help like the actual function that was running inside the server MCP server to give a correct response. A response could be anything, data or some returned result from an API. Now, we discuss kind of architecture, how it works, but we still might have questions like, does MCP really simplifies the things, or is it kind of making it more complex, right? Because earlier we had a function call, we used to just do a define function, attach it to our LLM. If were using something like LangChain or something, we would just attach that function tools equal to function one, function two, and those functions would be used. But now we are having some server, we are having a client, host, clients, and a lot of things, right? Something called a sampling. So does MCP really simplify the things? That might be a question. So to answer that, there is an example of this LXT problem. So like L times T problem, which is the biggest reasons why protocols like MCP are needed. So imagine we have like LLMs and T number of tools to connect. This tools requires L times T individual integrations, like creating a lot of maintenance overhead. So let's say without MCP earlier, for each LLM, we needed to create an integration with that particular tool. But after MCP, what happened is uh, each LLM application just needs to implement the MCP client once, and each tool also needs to be only exposed to an MCP compatible server once. Once that happens, MCP take cares of all the communications which the LLM application will require. So let's say there are three tools integrated with MCP. If an LLM wants to respond to a user query, it can just go and ask MCP what are the tools available for me to use. MCP will say that we have three tools. Here are the descriptions of the tools and what input the tools require, and then LLM will simply guide uh, and make a request to the MCP server, like the particular server to, and pass in an input, and it will get its required response back from the MCP server. So that is how, like, instead of building, like, let's say in cases you might have seen certain websites where there are hundreds of AI agents and hundreds of integrations available. In those cases, we will be building hundreds to thousands custom connections for each agent, each tool. But when you have MCP, you just need to build one interface on each side and just plug in together. So that's why, if you remember, there was one metaphor used for MCP, that MCP is the USB for the AI. So that is why it's kind of more easy to plug in and plug out. So yes, that's why MCP solves this problem of uh, L times T. And if someone wants to visualize this, like if someone doesn't like didn't got an idea, so let's say just imagine you have three applications. One is a chatbot, one is an assistant, and one is a voice agent. And we have four tools. One tool is an calendar API, one is a weather API, one is a CRM system, and one is a knowledge base. Now, without MCP, each AI application would have to create a custom integration for each of these tools. Meaning, if you see, chatbot needs to be connected with calendar, weather, CRM, knowledge base. Similarly, email and voice agent would like you need to pass these functions to all three of them. But now with MCP, each AI app you can simply connect it with an MCP. Like you add a MCP client for each app, and each tool you implement a MCP server once. And MCP protocol will handle everything. So what happens is you have three app plus three tools, which makes it instead of L times T to L plus T. So what is the like kind of a result we get is less complexity, much faster identification of tools, and tools also become reusable across LLM powered system. Meaning, let's say today you are developing an app with LangGraph. You made all the integrations, you wrote 200 300 lines of code for different types of LLM tools, and all those tools you created. Now after certain time, let's say there came a more better LLM orchestration framework, you need to switch to that framework. Now what you would be required to do is you need to rewrite those functions for those newly created framework if you want to migrate to that framework. But instead, if that framework supports MCP, all you need to just create MCP clients in that framework, because MCP server will still remain intact. Like the way they used to perform, they will remain the same. All you need to do create is MCP client for your newly created framework, and then it will be integrated very easily. This is the reason what makes MCP powerful. It just simply makes scaling across LLMs and tools more manageable than the previous methods which we used to do. So to understand more like kind of how all these different components of MCP, the overall protocol works together is, so you have a host application which also consists of an LLM, which also has an MCP client. Now on the host application, you will get an input from the user. This input would be processed by the LLM and passed to the MCP client. So the host, when it processes the input, technically the LLM tries to identify the intent of the user. Once it identifies the intent, it will generate some explanation of the intent or some kind of a response that the LLM needs to find these details and the user is asking for this particular specifications. So what happens is, after the post processing by the LLM of the user input happens, this particular post process response gets sent to the MCP client. The MCP client sitting here in the middle is responsible for orchestrating the overall communication between the host application and the MCP server. So it does a certain few things. It first connects to the server, then it sends a query to discover what capabilities are available, like what tools does the MCP server has. After it discovers, like the MCP server will return a list of tools it has. So MCP server will now understand. So what technically MCP server sends back is, it's a list of tools along with the descriptions and the input schemas of those particular tools. So they will be sent back to the client. Now the MCP client will uh, understand what's possible, and it will send a request back to make a request to run a specific tool based on the what LLM has suggested to the MCP client. Then the server executes this request, be it an API or some query, into the database. Once it executes that request, it sends the result back to the client, and then client is responsible to send this result back to the host application, where the LLM will generate a final user facing response. Like MCP server's response could be a JSON, or could be some overall query. Let's say if it was some data extracted from a database, it could be 10 10 columns, but if the user needs only 3 columns, the LLM will filter out the response in a way that it only shows the 3 columns or whatever actually the user wanted to get as a response. So that is how the LLM will form the final response. And here, if the LLM is not satisfied the response, or the LLM feels that it still didn't get the response which the particular user was expecting, it can use the sampling method which we have discussed. Sampling, in a sense, it will send back a request to the client that I didn't want this type of answer, so you can again go back to tool and maybe apply this query, or maybe try to fetch new data from the API. So that is why the overall communication here happens via JSON RPC, which is a bidirectional, which provides bidirectional support, and the sampling methods handles all this stuff. Yeah. Now, as we discussed, like JSON RCP is running, sampling is happening, but if we want to see how JSON RPC actually works, so we'll just see how the JSON RPC message format is. So let's say an LLM wants to know what tools are on a server. The MCP client will send a JSON RPC request to the server like this. It defines what version of JSON RPC is, the ID, like it is kind of a unique ID for a request. Then what method to execute. So tools slash list, this method is particular to an MCP server. And if there are any parameters that has to be passed. So usually for tools list, like when you are just listing out the tools, there are no parameters passed. So parameters can be used for other tools. So the tools that actually reside in the MCP server, whenever and client request to the server, here in the method section, it will actually pass the correct method of what particular tool to use and what input parameter it has to pass. So if the server gets a request like this, the server will reply with a JSON RPC response containing the result. Once it gets the report, so okay, so not the report, response. So this is how kind of a response you will get. We will get a response like tools. So here if you have only one tool, so here add it as it only had one tool, the tool's name it gives, DuckDuckGo search, the description of the tool, and if any input schema is there. So here there was an input schema, but it was kind of a huge JSON which couldn't be fitted here in the slide. So haven't included the input schema here, but here in the input schema, it would usually be what are the inputs to this particular tool. So at the end there, at the server point, there will be a function which will be expecting certain arguments. So arguments could be let's say query, or it could be like let's say if it was a chatbot running, it would be a chatbot query plus some authentication parameters. So based on all of that, that kind of information would be included in the input schema, that this particular parameter is a string, this is an input. So the LLM can actually pass particular information to the tool so that it will be able to get a correct response from the server. So yes, and by using JSON RPC, MCP supports structured requests and responses, and it also includes incremental updates. So, and built-in error and cancellation handling. So in case of any error that a server says that while executing the function, there was an error, the MCP client, with the help of LLM, can identify what the error was and maybe make another request with an updated input schema or with an appropriate input for the server to execute. Now, incremental updates, that specifically means uh, one thing to remember is MCP is also stateful. So we'll just see how it is stateful and how it does the incremental updates. But before that, uh, as I mentioned, the MCP is also linked to USB port for AI because it serves as a universal standardized interface that enables seamless connections between LLMs and a diverse array of tools, sources, and services. So if we have to kind of uh, summarize it, it abstracts away the need for custom integration logic for each application. You don't need to write code every time for a new framework, every time for a new LLM, and make a custom integration for the tool. So the idea would be as long as both the sides, the model, the tool, they speak in the MCP language, they can connect effortlessly without need of any custom integration. So taking an example of USB, like if you have a USB, it integrates with any device to any device. Similarly, if you have a gateway like MCP, it can make very easy for the integration of any sort of an LLM with any APIs or database. It just makes like you just need to make tools and LLMs MCP compatible and it will just work seamlessly. Yes, now coming to the stateful context. So the traditional REST API usually are not does not store the stateful sessions on the server side, but MCP server actually implements statefulness, meaning it stores the session context created between the client and the server. So here incremental interactions or incremental updates, meaning the previous interaction between the client and server is stored. So whenever the client makes a request to the server, if needed for the LLM can also read that particular history, and it can be able to find if there is some changes are required to make a change to the response. So that is how, like, it also maintains a history, and where it helps is because sometimes uh, like in earlier function calls you might have needed to send the history or the payload, like the overall payload again, but this time the MCP will handle that history and will maintain the uh, multi-turn conversation interaction between the client and the server stored somewhere. So that is what makes MCP bit more faster and more efficient. So the core features or the core capabilities that MCP can offer you. So this is like kind of the four capabilities MCP offer. There are total four feature or four capabilities available to us. One is resource. So resource, they represent static dynamic data that LLM could read. So resources are more kind of file contents or data that can be accessed from some local files like local.txt files, something like that, or from local stored databases. Resources are always read only. LLM can read them but do not modify them. And one interesting note is the resources are controlled by the host application and not the LLMs, which means that LLMs do not call resources when needed. It is up to the user to decide that the whatever the UI of an agentic framework or the ID user is using, the user is capable, like the host application user is using, the user can identify these resources and then based on the resources make a request to the LLM or make a request to the agent to perform certain action. So that is how it works. It is, and one more important thing to note will be you do not uh, kind of expose uh, like like what do you call as proprietary data or data which cannot be exposed to public. So those kind of data you must not put it in resources, because then it will be open to all whoever uses that particular host application. Then coming to the tools. So with respect to tools, these are callable functions or actions that LLM invokes. So these tools are identified by unique name and are provided a description. Description defines the tool's functionality and what kind of actions those tools can take. The more better description you give, the more better it is for LLM to understand the capabilities of a particular tool. And the creators who creates these tools, they also define a JSON input schema so that LLM can also identify what input the tool accepts for this what input the tool expects from the user. So in case if the user has not defined any particular input, the LLM can go back and ask the user for that particular input, that I also need this input to give you a proper response. So that is how a JSON schema is also defined for the tools. And as we discussed, it all gets facilitated by the LLM. So tools is what is LLM controlled, and once an LLM makes a structured request based on all the information it has, once it is satisfied that it got all the inputs required from the user to actually run this particular tool, it will pass that request. Server will execute the logic and return the result either in form of a text or a JSON in the way that particular tool was defined to do that. Then we have prompts and sampling. So prompts are essentially predefined message templates or kind of a workflows that help guide how the LLM should respond. So these are also actually user controlled, and these are technically showed or surfaced on the application UI. The user can make use an already available prompt, or this particular prompt, like when say you are exposing an agentic framework, you can also handle uh, like you can actually hide this prompt, and whenever user makes a input request. So we have seen in a lot of cases that not all the users are technical, or they know how large language models or AI actually works. So you facilitate the interaction by providing an extra prompt under the hood, and that extra prompt would be attached along with the actual user input, and that kind of process will actually make the interaction more meaningful, because the user will be able to get a response to that. So for example, you created some AI application for non-technical users, for sales team or marketing team. So you see that they were not able to get a proper response to the query. So what you can do is maybe you can create 3 to 4 prompts, and you develop them and put it under the hood, meaning that users won't be required to put those prompts, but when user makes a query, that prompt would be added to their query and then passed to the uh, passed forward, and the LLM processes it. So the LLM, if required, can make a question back to the user that do you meant this, or if you can provide me with this additional information, it would be more better to form a response. So that is how people who might not be very much good with using AI-based tools, they can actually get a proper response from the LLM. So it helps set the initial context for the LLM's response. and make interactions more consistent and structured. And then finally, we have sampling, which is a mechanism which server uh, where like kind of the server can ask the client to perform an action using the LLM, like enables more dynamic and coordinated client server interaction. So to like kind of recap, resources let the LLM read some sort of a data which should not be like uh, public like private data or some data which is your organization's IP. It should be some public data or some standard basic data which the user can refer through. Prompts, it can guide how to think or what action to take based on the user input. Tools let the LLM take the action, like can make a request, get a result, and pass it back to the user. Sampling facilitates the back and forth collaboration between the client and server interactions. So this kind of gives an overall view of core MCP features. Now we covered kind of the core concepts and architecture. So let's go ahead and take some look at a certain hands-on tutorial. So, but kind of before that, we will take a look at a bit of a history of the MCP, like the original MCP SDK that was released with the official launch of MCP by Anthropic. So when the official MCP SDK was launched, it got launched with Fast MCP 1.0, and it provided foundational support for the MCP. Like it enabled the developers to build clients that can connect to any MCP server. You can create MCP servers that can expose tools, resources, prompts, can handle sampling between the clients and servers. Having standard transports, like this has some internal transport layer, like we have many layers in a network architecture. So the transport layer architectures, the STDIO, SSE, and streamable HTTP, it has this standard transport functionality, which it already came up with in the fast MCP 1.0, and it handles all the MCP messages and the lifecycle events. But after that, this was kind of not publicly available. So FastMCP 2 was released, which is right now an actively developed successor to FastMCP version 1. This is open sourced, and it expands the capabilities of the FastMCP version 1. It includes server proxying, it enables authentication, it gives more advanced client features, it is more natively integrated with Open API and Fast API. Like we have like multiple new libraries where we can convert our already existing API endpoints directly to MCP tools. And Fast MCP 2.0 tends to increase the modular approach, how to create the client and the servers. So that is how it makes it more simpler. And as per the official repository of FastMCP, it is the recommended path upgrade, meaning if you are using FastMCP from the original MCP library, FastMCP version 2 is recommend to continue building your MCP servers and client instead of version 1. And if you are just starting out, it is better to start the version 2. So now, like we just understood, like kind of what fast MCP is and the fast MCP SDK. Sorry, the MCP SDK, how it was launched. So now we are actually going to take a look at creating our first custom MCP server. and how we can already use some predefined tools that are made public by MCP itself, or in case someone on GitHub makes a tool public, or some other place where you can just download the server information and run it locally onto your system. So that is how we will see two approaches here. So I have added the link here to FastMCP official repo, which you can refer to, the which consists of the version 2.0. So these are the two code tutorials uh, where we are going to see this tutorial. So I will just reshare my screen. So when this PPT would be shared, it contains the direct GitHub links. So onto the GitHub links, you would be able to access both the tutorials. So it contains the README. The README will contain the overall setup instructions, what you require and what you need to install to make this tutorials running. So we'll go through both the tutorials one by one. So starting with the FastMCP DuckDuckGo server. So what we'll essentially do here is, first let me walk you through README. So for this to work, you actually need a MCP client. Now, if you have clouded desktop and you want to experiment it for your local development, you can like the clouded desktop itself comes with a client of its own. So you can install the clouded desktop. You can go through this link and you will be able to install it for Windows, Linux, or Mac OS, whichever system you are running. And for the setup to run this, you can use pip, like the standard Python package installation library which we have. But here MCP suggests that ideally you should use the UV. So UV is an better approach. It is kind of a like more faster. It implements the stuff like 3 to 4 times much more faster than pip. So you can install UV locally, like using this particular link. If you go and there will be a PowerShell function to run, you can directly run that function into your PowerShell, and you will be able to run that particular UV inside your local command prompt. But there is another approach as well. If you already have a Python environment, you can technically use pip to install UV as well. So both ways are fine, but the more better approach would be to use and install UV as a separate installer out of any of your Python environments. Then once you install UV, you can create a folder wherever you want your targeted server to be. Once you create your particular folder, you can simply go to your target folder and run UV init. So what UV init will do, it will initialize the uh, basic files that are required to run a UV project. So technically we have PyProject 2ml, uv.log. So all this are generated by UV. I will not go into like why they are more useful, but it's just that that is what makes UV more faster and efficient than pip. Not technically faster, but yeah, it helps. Like it is more similar like poetry if you have used. Then to create a virtual environment with UV, you can simply just again in your terminal type in UV VNV, and to activate that environment, you have like commands like .vnv scripts activate. You can activate your environment, or you can use source vnv bin activate. That will for Linux or Mac users, that will facilitate and activate the environment which you have newly created. So whatever the name of your particular folder would be, the environment will be created with the same name. And then to install packages, so we will add two packages here. One is fastmcp. So fastmcp, we are not using the latest version. The latest version is somewhere near 2.3, but we are going to use version 2.2 because in the latest version there is a bug which does not let the uh, development server of fastmcp run properly. So 2.2 is the version which runs perfectly. So we're going to use that version, and then the DuckDuckGo search, which is the tool which we are developing, like adding a web search tool for an LLM to run on. So we'll do UV add DuckDuckGo search. Then uh, once we are done with this, we will go to our main.py. Here you will actually have your actual server code. So one thing is you will be importing from fastmcp, import fastmcp from DuckDuckGo search. You will import the functionality of DuckDuckGo search. Like this is all available in the DuckDuckGo search documentation. What are the different options you can use to make a web search with this DuckDuckGo search library? So first thing would be you needed to create a initialize a MCP server. So how you can create is you can name it as any variable. We are naming it as MCP equal to fast MCP. You name the particular server and what version it is of for the server. Then we can add a tool. So here we are going to add a tool. Tool name we will give it as DuckDuckGo search, and we will provide a description to this MCP server that uses DuckDuckGo search API, and then you will mention the actual like the function of the DuckDuckGo search library that needs to be implemented. So this ddgs is the function. It will do dot text query and max results equal to 5, meaning I will only have like whenever the query gets passed to this function, it will only return 5 results, and upon the like results whatever we get, this results will be passed back to the LLM, where LLM will read the user query, read the response from the particular tool, and finally form a response for the user. So what we are going to do is we're now going to run this particular server. So to actually run the server, what you need to do is first you need to actually do fastmcp install main.py. So if I just open a terminal, I will activate the environment. So what you will do is once your main.py is ready and once your all the installations are ready, you just need to do fastmcp install main.py, which will install this particular server. So it says added server to Claude config because by default this will add it to the Claude. So after this, once you install it, what you need to do is you need to actually restart this Cloud Desktop's configuration. So I will just go, I will quit it, and I will just open my Cloud Desktop app again. So on the Clouded Desktop app, if you want to see where your Clouded Desktop configuration is, I can click on here on the top left, File, Settings, and there is an option of Developer. So on developer, you will have this DuckDuckGo search MCP server. It will show you if it is present or not. And when you click on edit config, it will land you here. And then you can simply click on here, Clouded Desktop config, where it will show you all the MCP servers which are present for you. So DuckDuckGo search MCP server, which we have, and it's the arguments along with that, how it runs with fast MCP, and what is the function to run this fast MCP run, and the function, it will involve the overall path, so it can be ran anywhere, like the server will keep running. So now at this point of time, even if you try to make a query into the Clouded Desktop, it will not be able to use the tool because it will throw an error, because actually this server is installed but it's not still running. So what I can do is I will go fast MCP run min.py. I can just enter. This will start the MCP server for us, and I can make request on the Clouded Desktop app, which will act as a host application for me, which consists of client and also the LLM. So the LLM, the and Clouded Desktop users is the Cloud Sonnet 3.7. And in case we want to see the overall yeah. So when we do fast MCP main.py, so it will open a developer server option for us. So I will just click on this link. So this opens an MCP inspector. Here, first you need to click this connect button. Once you click this connect button, if it shows you connected, that means your server is now running properly. And here you will see all the options of resources, prompts, tool. You can go to tools. You can click on this list tools button. Here it will show you the DuckDuckGo search, MCP server that uses DuckDuckGo search API. And once you click on this, you will have a direct option to make any search for this. So let's say if I click here, let's say I will just simply put capital of India. I will run it. So it will show you the response from DuckDuckGo which we have received. So if you see, this is a list of outputs, the 5 outputs the DuckDuckGo search is giving: New Delhi, Wikipedia. Uh, so this is how the server executes this request. But if I go to Cloud, and here, if I say, if I ask for some statistics, let's say GDP of India 2024, if you see, it has started using the DuckDuckGo search. The LLM automatically requested for the list of tools. It got a list of tools and identified that DuckDuckGo can help it search over the web. Then it passed the like what request it made to the tool, so it passed the query, because query is what we have defined here in our function. If you remember, query, that is what the argument we have given. So this will pass the query and it will get the response from it, and based on that response it will give an overall response, like based on all these things, body of the responses which it has received. uh, it will generate a response. Now, in case if you wanted to make this more better, so in that case you would have required to actually create a tool that web scrapes the data, and based on the web scraping, maybe you would be scraping some news website or some Wikipedia, and based on that web scraping, you will get a more better result, because what happens is it only goes to DuckDuckGo, searches for something, and whatever the title it get as a response, and whatever the 3-4 lines snippet output it gets, based on that snippet only, the response is generated by the LLM. But to get a more comprehensive response, some web scraping is more suggested based on the tool. Maybe you can still have DuckDuckGo search. Once the DuckDuckGo search returns you 5 links, maybe you can have a web scraper which scrapes all these 5 links and returns a overall scraped data back to the LLM to generate a response. Now, this was with respect to uh, like how we created a one simple fast MCP based MCP tool. Now then we discussed about resources and prompts. So with respect to resources and prompts, as I told you, it is more host controlled, host application controlled, not LLM controlled. So if you are using something like Cloud Desktop, how you can access this is you would have this plus button, and then there is an option here, add from DuckDuckGo search. You will get this data configuration. If you click here, it will show you that resource, what resource it had. So like I just put in a dummy here, dummy text here that contains the configuration of the current server. And in case if I wanted to use a prompt, so this is a prompt. Ask about topic. Now here, if you see, it isn't like it's exposing me, generates a user message asking for more details about a prompt. So whenever the user will enter a topic, so let's say if I go and enter a topic about, I want to identify the statistics of India. So ideally in this case, I'm hoping that it asks me back what kind of statistics you require. Yeah. See, the LLM identified made on the topic. Now it is based on the already attached prompt. It asks me what specific aspects of India are you interested in. So that is how when adding an extra prompt can help can help the LLM respond in a more better way. So that is why we have prompts and resources also available for us. And then if I go back, uh, we will be seeing another way of using MCP servers. So I'll just close this terminal. Another approach is already ready-made MCP servers that are created by uh, officially created by the MCP and Anthropic. So here in the external servers, if you go to this particular link, so model context protocol servers, so this particular GitHub repo contains a overall comprehensive list of all the servers that are available. It contains thousands of servers already publicly created by people and created by Anthropic. It has all the connections between all the cloud sources, data sources, Google APIs, Microsoft APIs, almost everything. So, for example, how to use this already public servers, what you can simply do is but yeah, before using it, like for this particular demo, we are using the Postgres server, MCP server, which will allow us to make connect to any locally stored Postgres database. So if you actually, oh, sorry, if you actually go to, sorry, um, yeah, if you go to the Postgres MCP server specifications, it will mention running it with Docker. So in case sometimes there would be a particular requirement for Node.js or NPM. So to facilitate that, you would require to install that particular Docker desktop or Node.js into your system. Then and then only that server will be able to work fine. So for Postgres, if you don't have a Docker desktop, you can install this from the link that is already available in the GitHub repo. And Cloud Desktop, uh, is what again you would have like installed to make like you have a MCP client connect to the MCP server. Now here in this case, it is more easy compared to creating a custom tool, because all you need to do is open your clouded desktop configuration, and if you go back to the original this particular repo for the Postgres server, it will give you this particular command what you need to add here. So I can just go if and what I can do is I can just add a new list here in the MCP servers. I will just add a new dict here in a JSON format. Postgres command is Docker, and I will pass it MCP Postgres and whatever database I want to connect to it. So this Postgres server, like as my local is connected with a user and password, that is Postgres and password is root, I need to pass user colon password at the rate host.docker.internal. So why host.docker.internal is because whenever a Docker desktop needs to connect to a local host, they need to use this particular host.docker.internal instead of the local host or the particular link which we have like 127.0.0.1. Instead of that, for Docker to connect to your local host, it needs to particularly use this host.docker.internal. Then you pass in your port. So the Postgres usually runs on 5432 port, and then you pass in your database name. So once you pass in your database name, I will also open my Postgres. So for example, I already had a conversation with it regarding my data. So we'll just check for what like RTA is a database which contains data about road accidents. So I asked it, can you check the RTA dataset? And yeah, one more thing to remember would be, sorry for that, when you add this for the very first time here, like when you just added your server information in the config.json, you need to again restart your clouded desktop. Once you restart your clouded desktop, what it would do is, if you'll go and open your Docker images, you will be able to see MCP Postgres, and inside the containers, you'll be able to identify what image is currently running. So even if I go and delete this container and restart my clouded desktop, it will again restart this particular MCP Postgres image as a new container if it doesn't find any container running. So that is how once you add a new server information in the config.json, you need to restart your cloud to make all the things, internal things work smoothly. I will go back to my cloud desktop. Yeah. So I asked it, can you check the RTA dataset and let me know about the columns in accident dataset? So it identified that there is a tool available to find, like there is a database available that it can query. So it uh, did this particular query, selected this, and it got all this informations. So based on this information, it gave me this overall information about the columns present inside this table: area accident occurred, lanes or medians. And if you want to confirm this, yeah, accident info columns. So this was a list of columns. So area accident occurred, lanes or medians, road alignment, this all up to accident IT is present here inside this returned result query. But now to see a example of sampling here, like we discussed sampling, but we still didn't see an example. So let's say if I go and ask it how many road accidents occurred in India in 2025. So what it identified from my request is, if you see the RTA dataset I have access to doesn't appear to contain data from 2025. and I don't see date or year information in columns we examined. So it made a request, it got a response, but now it identified that there isn't any data available. So it goes back and check for how many number of schemas are available. Then it again goes and checks for other tables. It went and checked for basic info table. Then it checked what are the other tables available in RTA dataset. So it did a lot of things and then finally identified that maybe the data is not available, and then it made a DuckDuckGo search. And based on the what search it did was road accidents India statistics 2025, and based on the results from DuckDuckGo search, it just gave me a response. So that is how the sampling thing worked here is. Uh, it keep reiterating until it got a, like, the LLM thought that it was a satisfactory response. So that is how sampling also works. So this is how, like, the overall picture is, how like we created a custom tool, and how we created or make use of openly available servers, and then we can directly integrate them into our existing client host applications. We can simply, if they are running with Docker, we can install a Docker desktop and add it simply over to Cloud Desktop JSON and attach it so that it can work. So yes, and one thing, like, we'd like to add here is, due to certain time constraints, like, we won't be covering more like demos like the LangGraph and Olama ones mentioned into the uh, like the poster shared, but we will have another session totally dedicated on how to integrate this particular tools, sorry, not the tools, how to create your servers and then create MCP clients and attach them with some host applications like LangGraph or Llama Index, and how you can use an open source LLM with Olama. So that is what we will be doing it in a separate follow-up session. But yeah, for today, this was our overall focus, and yeah, that is it from the session. So Saurabh, shall we now open it for open Q&A? Is Saurabh present? Okay, Saurabh is not present. I will just open your mics. Just give me a minute. Yes, this link is getting recorded. Uh, this PPT will be shared publicly onto the LinkedIn, and the people who are already associated with the Gen AI program of TMLC, they will get this particular recording, and they will also get this PPT where they will be able to access the code. Okay, I'll just open the mic. Just give me a minute. Yes, now you will be able to use your mic. So yes, please, you can ask your questions. So let me try. Can you share link for join this community? Okay, Kishan, you can visit TMLC's LinkedIn account, and there you will get a link to join a WhatsApp group. You can go there.
Hi, Chirag.
Hi, Shikhar.
Hi. Hi. Thank you so much, first of all, for taking us through the concept of MCP and then showing a demo. My question is, how is the MCP performance so far in real world at enterprise level, especially pertaining to scaling and the performance? Do we have any examples? If so, if you can share that about that.
Understood. So unfortunately, MCP is still in building phase. A lot of like I have seen few people implement that, but like as we say, it is not yet still scalable at the level which we want. So that is why it is still under development, and we will maybe see a lot of development in the next coming year.
Okay, Chirag. Yeah, thanks.
Okay, I will check in the chat and ask a few questions. So yes, one question from Harsh is, if you don't provide tool names, then also yes, MCP can discover what tools are available to us and execute that. So MCP technically, as we like kind of discussed, it like the client host will ask the client, LLM will ask what tools we have. Client will send a request to MCP server that please give me the list of the tools you have, and based on that list, LLM can decide which tool to call. Okay. One question from Anand was, the figure shows one-to-many relationship between client and server, but your slide says one-to-one relation. Okay, so like the figure just showed one single client and one server, but when we saw the actual overall picture, it had like the host can create and manage multiple clients, and each client will have a one-to-one relation with the server.
So it is many to many, right? The host can have many
Many to many.
clients, right? Yeah. Okay. That's what I
Correct.
thought. Okay. Thank you. Thank you.
Is client and host same when interacting with MCP server, or we have to implement client also when wanted to communicate with MCP server? Correct. So when we have like as an example, we used Clouded Desktop, which already came up with a inbuilt client. But in case you are working with LangGraph or Llama Index, there you need to specifically define your client, so which can connect to the server. But otherwise, if you use VS Code also has extensions where you can directly install an extension which consists of an MCP client. That is also possible.
So in both the cases, we don't have to build the clients. Is that right? MCP clients, or it's always available in the marketplace. Can you
Uh, there will be
can
a
you
lot of
elaborate on? Yeah.
implementations. Yeah, there will be a lot of implementations available for them. So let's say if you are going to use LangGraph, LangGraph already has an inbuilt function which is stating that something called as connect to MCP or something. I don't exactly remember the function name, but it has already given a function. So you can just simply do that function particular call, pass in the name of the server and multiple things, and it will be able to connect to that particular server. As simple as that.
Yeah. So so now we don't have to worry about building the client or the server. So those, for the most part, may already be available, right, for the tools.
Correct.
And
Correct.
yeah, well, only
Most
only
of
when we have building
Mhm.
custom solutions, we have to have our own MCP server and client built for that. Is that right?
Correct.
For example, right? Okay, okay, got it. Say if I build a CRM myself, I may have to create a MCP server and client for that. Yeah.
Correct.
Okay, got it.
I will share the link
But,
to the GitHub here.
yeah, Chirag, one more question from Debashish here.
Yes.
So, as you mentioned, for the when it takes DuckDuckGo search, it takes the advantage of suppose the LLM is recommending some set of URLs, and then from there it can further do the web scraping, right? So in that
Correct.
case, for means as a private enterprise level focused search engine, if I want to build with DuckDuckGo search, then for the set of URLs further to take the instant search, and then
Mhm.
after scraping recommended URLs will be prioritized, right, in the top priority, and from there
Correct. Correct.
LLM will further
Hmm.
get the. So
Yeah, please continue.
include will it not include a separate, I mean, search-wise over computational load for MCP, or the MCP client will take care of that for the.
Client is kind of independent of server, right? Server will run that
I
particular
mean MCP server.
code. Yeah, server will execute that particular task. So that task, if it is more heavy, you can have a more better server to run that on. That is not an issue with that. MCP server will be something similar to kind of, let's say you created a fast API endpoints, you put that into a AWS cloud. The MCP will be something similar to that based on what kind of complex computations your particular this MCP tools it implements. You just need to have a specific setup for that. In case if you are exposing an AI model via the MCP tool, you need to might be also having a GPU is a possibility, because if it is a deep learning model, you will also require to have that GPU to run that particular deep learning model. So yeah, depends upon the kind of complexity of tool you have.
Okay. So that means the ultimate goal will be in that case, even for MCP server running in the cloud cluster, the parallelization techniques has to be scaled properly for accommodating the parallel web crawling or web scraping for the setup list, if the number of huge search URLs come by the LLM.
Correct, correct.
Okay, okay. Yeah, thanks. Thanks for the clarity, Chirag.
Then we have question from Vikas. Can you repeat the inspector? I'm not able to connect and launch inspector. Vikas, are you getting any errors when trying to launch the inspector? If you are facing some errors that it cannot launch the inspector, uh, sorry, Vikas, I was not able to hear you.
Hello. No, I didn't speak. Actually,
Okay,
I have developed custom MCP tool on based on taxation. Okay.
okay,
So whenever I was trying to test it on the inspector, I was not able to connect even on the studio or even on the SSC. So it's
understood.
yeah. So that's the reason I just wanted to see, because one I have developed with UVCon. So I wanted to expose
Mhm.
that UVCon code to the inspector. I've given those URLs, but it is not opening. Means listing out all the. Whenever I'm clicking on connect, it is showing some error.
Understood.
It,
So, one thing, if it is like not that particular URL is opening, right? The inspector URL is opening, correct?
hmm.
But
So
you are not able to execute the tool,
yeah, on inspector,
or
as
uh,
you clicked on connect, it was shown
uh,
connected. The
yeah,
same I'm doing, it was not able to connect and showing me some error that it is, and I'm
understood,
not able to see those logs also.
understood. So I had this kind of a error.
Hmm.
What I did was I installed Node.js and it fixed the error for me. So if you can also try that.
Okay. So to run the inspector, we just need to use that model context protocol and then the inspector, correct, in the command in the terminal, and it will
Correct.
open it. And if our tools are already added in, because I'm running those through VS Code, so it should work basically, correct, in the inspector.
Correct. Correct.
Okay. Okay, I'll look into it. If any issues, I'll ping you.
Sure. Sure. Okay. I guess we are not having any more doubts now. Okay. I'll stop the recording.